and probability that it will finish in the money is probable. The standard normal distribution is going to be above that, or in Excel, norm as test. I'm going to since I'm doing the upper tail, 1 minus norm as test, 1.0239, which is equal to 1 minus probable z is going to be less than that number. Of course, I'm going to calculate that in Excel. Let's just do this. And let's do this z. One minus norm as this. So that's about 15%, okay? Volatility is so high that even with such a high what you want to call strike, there is still a 15% chance, according to the option pricing model, that this option is going to finish in the money. So it's going to be above 7.5. Whether or not it will be is a different issue. But it is paying a lot of premium for that now, 20 cents. But if you want that probability to be lower, then you're going to have to live with a lower premium. Alternatively, you can ask yourselves the following question. So we want to know what strike price to use for the covered call. The way we do this in practice, we ask ourselves, what is the probability that you desire? What is the maximum probability? For the option you sold to finish in the money. Let's say I want that number 10%. 90% of the time, I want the option that I sold to finish out of the money, which means, I didn't have to sell it at that price. When the time comes, I'm going to just renew it with a new strike price. Say that number is 10%, okay? First, find the implied z-score for that probability. That's inverse normal distribution. Probability. So desired z equals norm s inv 1 minus 0.10%, okay? Because I'm looking for the upper tail. Desired upper probability. Desired Z. Norm SM. 1 minus that. Or alternatively, we know the mean and standard deviation. Period drift, not drift. What was that number? 27 something. 2637. Implied return. That's the return if that strike price happens. Norm dot imp probability 1 minus the number you want, the mean and standard deviation. Current price 590. Desired strike. Take the current price, multiply it with that implied return. So 790. Well, since the stock has strikes only at halves, it's about, I would do about 8. Or I could do some of them at 7.5, some of them at 8. But I usually would do it at 8. But at 8, you only collect an option premium of 15 cents as of today, if that. At 7.5, you would collect about 5 cents more. So it's kind of a trade-off. And there is no kind of hard and fast scientific rule. You kind of decide what is that probable that you want to live with. I like flying a little bit closer to the sun, like Icarus. So I live with a higher probability, because as the prices change, I actually adjust those strikes. I mean, I'm teaching today, but tomorrow I'm not teaching, so I'm going to kind of look at it. I may actually roll these options to, depending upon where the prices are, to 7 or 6.5. But if you're doing this kind of as an automatic thing, you like a stock as an ETF, you buy it, you sell, typically 1 or 2 week covered calls. If you can live with 10% chance of that option finishing in the money, fine. You could do similar stuff for the covered puts, this time on the other hand. What's the implied returns? And the way this is going to work, on 24th or closer to 24th, I'm going to decide, depending upon the price then, what is the strike price for the new options that I'm going to sell. And for example, I can do it right now. I'm not going to, but I can actually, here's my options.